All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's May 18th, 2022. My name's Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, which just means that we help companies own their infrastructure in record time by building it together with your team and showing them the ropes. So if that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz to get started. For those of you new to the call, the format's very informal. My goal is to get your questions answered, so feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week. Our call today is recorded. So if you want to catch up on this or any past episodes, head over to youtube.com/cloudposse. And please hit those like and subscribe buttons. It helps us out a great deal. So with that said, let's jump into announcements for the past week. Tons of little announcements. One is that StackRox, if you don't recall, was an independent company not so long ago that Red Hat acquired. A Kubernetes security platform, you know, in the ballpark of Sneak and drawing a blank, and some of the other options there. Now StackRox is open source, so that's a pretty cool trend we see from some of these acquisitions, is they end up open sourcing the core IP as part of that. The next thing came up, I think I saw it in Hacker News. I thought it looked interesting. It's always a challenge managing access controls to Kubernetes and databases and so forth. Lots of products have sprung up over the years. Teleport has a solution for this to make it easier to access your Kubernetes clusters, your SSH services, your databases, and so forth. There's Strong DM, to a lesser degree Zscaler. Well, here's an open source alternative. It looks pretty snazzy from the screenshots, and it will help centralize the management of user access to different systems that you have and integrate that with your IDP. In this case, the example is logging in with Okta, and then you can see at a glance all the systems you have access to by doing a list, and presumably then have access to it. At this time, I think it supports Kubernetes and databases. I'm not sure what else it supports or what is on the roadmap. Other things that this reminds me of is like HashiCorp's latest product called Boundary. So this is in that zero trust category of proxies, I suppose. But the word zero doesn't even appear here, so I don't know if that's fallen out of vogue now. Anybody take a deeper look at infra than I have? And good luck with the SEO on this one. I think that could be a hard one to monopolize. All right. I was almost like not sure if this was a new announcement or an old announcement, because Heroku's been getting a lot of bad press, warranted bad press lately. So sounds like yet again, there's been another attack against Heroku, this time against the environment variables stored in CI pipelines. So now, and those used in review apps. So review apps are the actually amazing thing that Heroku did way before anybody else was doing this, was this concept of these short-lived ephemeral environments or preview environments. So that's what they call review apps. Unfortunately, those two were compromised. And I think it just goes to show that, like, Heroku's unfortunately right now a dumpster fire after the Salesforce acquisition and the brain drain going on at the company. They aren't able to keep up with everything changing here. So I don't know. I kind of almost expect the next announcement from Salesforce to be, "Hey, we're sunsetting Heroku. You got to get off in 3 months." Anyways, rampant speculation there. Anyone get this email? Well, you probably don't want to say so if you did, but sorry if you did. I'm excited about this announcement. So AWS Control Tower is a service I want to love and use, but we are having trouble fitting it into our paradigm. And part of the problem with Control Tower is that there are no resources to manage Control Tower itself. Control Tower itself is a fully ClickOps solution. You might recall the announcement at reInvent last year with AFT account factories for Terraform. It was a little bit of a confusing announcement because anybody who does Terraform probably was thinking like I did, oh my God, finally Terraform support for Control Tower. But no, actually it's quite different. It's about establishing a baseline inside of an account provisioned by Control Tower, and establishing a baseline for Terraform. You can commit a config file, I believe it's in YAML or JSON, to a Git repository. Control Tower will pick that up, and within 45 minutes, you have your net new account. As you recall, if you've been using Terraform for this, it takes only like a couple minutes to Terraform a new account. So it's awkward that Control Tower takes so long. Anyways, that's a sidebar. The real interesting thing here is that you can now continue operating the way if you have been operating like Cloud Posse, terraforming out your accounts and managing like your security or your core accounts, the audit account, and your identity accounts. However you do that, but now coexist with Control Tower and have Control Tower piggyback on top of what you have there. So this gives a way to maybe offer a certain portion of your users a self-managed account experience for maybe like developer accounts or sandboxes, while using your more strict and rigid system for provisioning accounts with Terraform. I don't know. I'm just trying to find a world where we can coexist until Control Tower natively supports API endpoints that Terraform can use. Any other takes on this announcement or why it's interesting?
Well, it's definitely interesting that for organizations that want to start using Control Tower that didn't start out with Control Tower, so they don't have to wipe out everything they have and to adopt it. I thought that was actually a pretty good use case for this new announcement, at least. Excuse me. Yeah.
All right. The next announcement I have was related also to AWS, which I was excited about, a small announcement. What the announcement is that basically Amazon has come out and said that now AWS SSO can be delegated to some other member account for administration. And historically, AWS SSO has always had to be in your root AWS account. In our paradigm, that's a little bit awkward because we've been provisioning this identity account in our organization. And it works really well when we use federated IAM with SAML, but it hasn't worked as well conceptually when we use AWS SSO. Now, technically, this changes nothing. The only difference is that we can now centralize everything related to identity in this identity account, while before we had AWS SSO as this exception in the root account and everything else in this identity account to manage role delegation between accounts in this way that we manage them. It looks like we got some artwork here on the screen. Clear that out. What was I going to say? Matt, anything else you'd like to add to that?
Yeah, so the only thing that, and I haven't had a chance, I've read the announcement, but I haven't had a chance to actually try it yet. But it says that you can manage from a delegated account, but I'm not sure if you still need to install AWS SSO in the root account.
Oh, I see what you're saying. Yeah,
it's actually not. It's actually not clear. So while maybe you don't need to then log into the root account to manage AWS SSO, which would be good, I'm not convinced that this means you don't still have to install it in the root account, and then it delegates all the permissions down from there.
Well, yeah, can you look into that later on? I'd be curious to know how it affects our implementation.
I actually created a blank organization so I could do it to test it, but I just didn't get back to it to actually test it.
Oh, you saw this recently already?
I saw it like,
oh, okay.
you know, a couple of days ago, but then I didn't get a chance to get back to actually test it yet. So, but I will. Yeah.
That's cool. All right, let's see here. Next, next announcement is just another controller for Kubernetes to manage resources in Terraform. I think this is interesting because, well, if you recall, I think 3 weeks or 4 weeks ago, we had a conversation, someone else in our community who has been developing for the past couple of years, their own controller for this. He was aware of the other controllers for there, and he shared candidly what some of his problems are working with Terraform in Kubernetes as a resource. And yet we see all these other providers, all these other solutions or implementations for it coming out. And I'm not sure how they address some of those fundamental problems trying to handle terraforming through Kubernetes. I think one of the big ones is any sort of approval workflow and understanding what the impact is of your plan before you apply it. You know, that's not a natural concept in Kubernetes that we typically like to see with Terraform. Additionally, the debugging process is that, you know, when Terraform fails, it fails pretty miserably. And how do you know what to do when it happens that way? And debugging, looking through kubectl logs isn't necessarily the best developer experience. So yeah, this was one of them. You know, HashiCorp has their own that requires Terraform Cloud. weaveworks has their own that works with Flux, which looks really interesting to me. Kind of curious about. And Rancher has theirs. I think they were one of the first to come out and do attempt to do this, but looks like the project was abandoned about 14 months ago and never broke experimental. At least they're honest, because I bet they're all pretty experimental. I forget who that was. Are you on the call today? Who's talking about their project? All right. Last announcement is a follow-up. We talked about Atlas, I don't know, this year at some point. Atlas is a language agnostic database migration tool. When I say language, I mean like framework. Like if you're using Rails, you're going to use Rake migrate or something for that. If you're using Python, something else and whatnot. If Java, yet something else. Here's a generic way of doing it that's language agnostic. Uses under the covers, it's using HCL as the format for defining your database schemas, and then it can come up with the migration steps for your schema. Well, they've now written a Terraform provider, so now you can bring all of that natively into Terraform itself. So Terraform can now be used to manage migrations alongside anything else that you're doing. Not saying that's the right tool for every company, but if your company hasn't selected anything today, maybe this is something interesting to look into. Any critical opposition to this?
I would not want to write my database migration schemas in HCL, but I just hate HCL in general. But yeah.
Yeah, I think it's one of these love-hate things. If you like the schema of HCL, if you like how it aesthetically looks, then maybe this is even more appealing. All right, that's all I had for announcements. Anyone else?
Oh, sorry, I was just going to say, like, to your comment that I would much prefer writing my database like migrations in SQL, like in the actual language of the database. Like it seems like no need to have another like abstraction layer above that for me, but I can understand why some people like that.
Yeah,
like a common way to do it.
Yeah, I can see that too. I mean, sometimes you spend more time just searching Stack Overflow for how to express this thing in this translation layer than
yeah,
you
exactly.
can do just in the raw. Yeah.
It's like some of the like ORMs have the same problem where they try to abstract too much out, and then you're just like, I just want to write a SQL statement.
I know exactly how to write the SQL statement. I have no idea how to do this. Yeah. Yeah. Cool. Anything else catch your eyes this week in terms of announcements? This is open to anyone. All right. So I want to jump into talking points. One of the things we noted we wanted to get back to was talking about the GitOps developer experience, but I noticed we don't have Vlad here today, and I really want him to be a part of that conversation. So we'll table this until next time when he's also on the call. Then we dug up a couple questions from the Slack community. I thought we'd answer on the call. They've already been partially answered. Let me pull that up. Whoa, that's a big window. All right, so the first question was, what ingress controller does Cloud Posse recommend? And the answer is, it depends. It really depends on your use case. And I hate that kind of answer, but let me explain. Our de facto go-to ingress controller is the Amazon load balancer controller. It supports NLBs and application load balancers. It's, you get AWS support if you deploy this and manage and run it. Most of the other open source controllers out there, you have to pay for some additional commercial support. If you're already paying for commercial support from Amazon, well, then this is now covered under that. So that's one of the reasons why I like it. But it gets complicated if you want to have true end-to-end encryption, as is pointed out here, where what we mean by that is encryption from the client all the way through to the pod serving that traffic. Now, inevitably, you're going to have re-encryption at some point in that loop. For example, at the point when it hits the Amazon load balancer, then gets re-encrypted and goes to the pod. And that solution is possible. We have implemented it. It's pretty simple. If you also then introduce Cert Manager can issue self-signed certificates for your pods and route traffic that way. There's also, when we're talking about end-to-end being a requirement, which is what Stephen Miller was asking about, this is also where some of the service mesh offerings come in that make that management of the TLS sidecar easier to do. And 99% of those, are using Envoy under the hood. There is another solution that we've gravitated towards for customers that do want the end-to-end TLS, don't want to manage the sidecars, and don't want to introduce a mesh. On Kubernetes in AWS, there's an alternative. So in that situation, you can use Ingress Nginx, which is the open source controller for Nginx. There's also Nginx Ingress, which is the Ingress controller, the commercial one by Nginx, the company. But the way Ingress Nginx works, it's a pod actually running inside of your cluster. And if you terminate the TLS at that pod and then require Nitro EC2 instances inside of your VPC, the cool thing here is that Nitro instances of a certain class automatically have TLS encryption between all nodes in that VPC. So then you don't need to do the re-encryption and you still achieve the same outcome. There's this is, I would say, kind of like a hack. It's a hack because, well, you're not getting some of the other benefits you would get if you were doing, managed TLS certificates, and you could actually do certificate pinning, or you could have, use the aspects of your service mesh to control who can actually control to that microservice by controlling the signing of the certificates themselves. If none of those are requirements, then the Nginx Ingress running inside of your cluster and the Nitro instance is advantageous. Now, there's many reasons not to use Ingress Nginx as well. The open source version, it's tremendously inefficient for large clusters with lots of pods, because every time a pod is added or removed, the Nginx process is literally rehopped to reload the configuration. And that rehopping process involves spawning off another Nginx process, reloading the configuration, and then passing all the connections over to that process. You don't want to be doing that 100 times, a minute or even more, depending on how many pods you're launching. There's another real drawback with Ingress Nginx too, or any kind of controller that works like Ingress Nginx that is based inside of the cluster, is it's not really aware of where the pods are and you could get a lot of cross traffic inside of your cluster, increasing the network transit costs. For example, you have 5 Nginx ingress Nginx pods running. It hits, you know, a node in availability zone, you know, 1, but it routes traffic to a pod in availability zone 2. When you're working with Amazon's load balancers, it's more intelligent, and it's directly routing the traffic to the ENI of the pod. And that's why the Amazon load balancers are superior to just ingress Nginx for performance reasons. Any feedback on that? So that's what Cloud Posse uses. If you subscribe to our newsletter, or you were attending office hours last week, you'll know there was a very interesting document shared. Let's see here. It was a comparison of all the ingress controller, well, not all, but it was like 15 plus ingress controllers. I don't see it here right now, but yeah, we'll share that. So Stephen, are you on the call? It looks like.
Hey, yeah, I'm here.
Was that a sufficient answer? Do you want to know anything more about what we do on that?
Oh yeah, really appreciate that answer. We tried doing it with Istio for the network encryption requirement, but now I'm kind of second guessing that. Originally, we did each pod with a sidecar, an Nginx sidecar that we just like configured our Helm chart, and then cert manager with a self-signed cert, and configured the ALB just to allow that. But because we didn't need authentication on our HTTP, we need the encryption. But now we're just doing with Istio, but that has come with its own set of problems. So
but you brought up it. So you tried what we've done before. You reached the limits of that. Then you wanted to do authentication. You looked at Istio. Istio is a lot better than today than it was when we were working with it a couple of years ago. They've addressed a lot of the upgrade issues. In general, though, I hate working with operators that are in the critical path of everything that you're doing. And since Istio is an operator managing that mesh, I'm terrified upgrading clusters running Istio unless we have blue-green clusters and can just literally, upgrade Istio in a separate cluster and then migrate workloads between them. But upgrading your live Istio control plane on a live production cluster is not something that I feel comfortable, recommending to customers. Since they're going to be responsible for doing it. And if you don't have some Istio subject matter expertise, if things go wrong, what are you going to do?
Yeah.
Did you look into AppMesh since you're on AWS?
No, that's one of the things I feel like I should have tried first.
It's one of these things, like the draw for Istio is frequently that, we want to run a platform agnostic mesh, so we could run this on GCP or Azure or Amazon, and that's great, but okay, you had a different set of problems if that's the case. What I like about AppMesh, though, is you get the benefits of the mesh with the benefits of AWS support. And I think that's not to be underrated, because when you are responsible for operating these things and things do go wrong, AWS support is pretty phenomenal from our experience.
And they also do that scary upgrade under the covers on their own for you.
Yeah, exactly.
Hey, awesome. I'll have to check that out. So yeah, pain points for us would be, so we have like our authentication. We have like an authentication service which is integrated into Istio, and so we'll have to just make sure our other service meshes works the same way.
Yeah, and or you guys also looked into API gateway rather, and using an authenticator on there. It's a boring architecture, but much simpler to understand.
We do have some Lambda functions behind API gateway that are integrated into our auth service. So I think it ought to work, but then we haven't got it as granular on the RBAC with the authorization policies in comparison to Istio yet. Okay,
makes sense. I see you asked another question here. At my company, we have on-demand environments we call ODE. Yeah, something we call Preview environments, and Heroku calls review apps, basically, which means that for any candidate change PR, we deploy an environment automatically. This allows for project managers, developers, QA engineers, etc., to view this version of code in an isolated and live environment. We run QA automation against these environments using browser automation technology after merging the PR changes are deployed to production. This has been working great for developer velocity with our client and server architecture. We have 2 repositories in play, one client based in React and one server based in Rails. It's and a candidate change to either repository, both the client and the server are deployed to an on-demand environment, selecting the main branch of the other repository. For example, in a branch cloud, thank you, Cloud Posse rocks in a server, we would deploy the main client branch and then Cloud Posse rocks branch of the server, the main branch of the Cloud Posse rocks. Yeah, exactly. That makes sense to me. Now, our company is moving towards microservices, and I have a challenge to make for on-demand environments for microservices. Basically, I'm having some trouble with this project. In the current ODE design, basically all services are redeployed for a candidate change in any other repo, in this case, the client server repositories. Also, the database for the repository is deployed from scratch and seeded fresh for each branch. This doesn't seem wise in the case of microservices to deploy everything for any change. So maybe some sharing should be involved. For example, one could imagine sharing the server for any client change. I have trouble making this work flawlessly. All right, or seamlessly. This is really interesting because we've talked about this exact topic multiple times, and I think you kind of recapped the challenges and like the false promises of doing these on-demand environments for microservices. And I wish we could find that recording for you quickly, but it's on our YouTube channel. And Vlad Lanosko was talking about, how this might be symptomatic of other problems in your organization, basically not having sufficient local development environments or the ability to leverage feature flags. So basically, we're overloading the deployment methodology to do something comparable to what could possibly be accomplished with feature flags, which is a much simpler system to orchestrate. Now, I'd like to entertain what you mentioned here and break it down into 2 parts. So the first is, what are you trying to solve? Is it the developer experience or the QA experience? If it's a developer experience, maybe you just got to solve how to do better remote development environments for microservices. And for that, there are a lot of solutions to look into. There's like tilt.dev, garden.io, scaffold by Kubernetes, by Google rather, and so forth. And that's the direction we're heading. We were promising these preview environments for a long time to customers that they could do through their CI process because it seemed like it would make sense. We just create a new Kubernetes namespace, we deploy all the services in there, and it should just work. The problem is, you mentioned that you inevitably have all these edge cases that make it complicated in terms of the development workflow. Maybe you're working on an epic that's modifying 3 different microservices and you want to test those in an environment. But if you do that, what are you going to do? If you depend on any webhooks from third-party services, this whole thing really falls apart. Like, especially if you're depending on like Twilio or something, it's just not feasible or scalable for any kind of app in every kind of situation. Now, you might not have those requirements yet, but if they are on the roadmap, then also consider that for future longevity of what you're building. The other is speed and performance. Building up all these large microservice ephemeral environments could be very slow. And then you don't have that feedback loop that you really wanted. The problem is that if it takes 30 minutes to go through CI and push an incremental change through all these systems, that's not really great. Even if it's 5 minutes, that still sucks. These remote developer environments that are optimized for Kubernetes, what's beautiful about them is they operate in one of 2 modes. One is they're literally running the container on your local developer machine, so you can get the live reloads and everything working really well. Or 2, they're allowing you to deploy directly from your machine straight to that image in the Kubernetes cluster in that namespace. So it's also really fast. So we're talking seconds to upload images, seconds to update services rather than tens of minutes or several minutes.
So So in this, so it's kind of like you do sacrifice a little bit of isolation in these cases. Is the idea that it doesn't matter as much? Less people per app?
Here's where we're headed with release engineering. Take it or leave it. Is three scenarios that you're 3 or 4 scenarios that you're optimizing for. You're optimizing for relatively current preview environments, on-demand environments in your case, for single service applications. So like a single microservice can be tested and spun up in a cluster. Now, if that's going to be useful or not, totally depends on the application. Probably not, especially in a tightly coupled or distributed type of system there. The other situation is for QA. And for QA, what you need is to be able to test this PR in context of a couple other PRs, maybe in some stable environment. And for that use case, what we do is we have a certain number of discrete named QA environments that are owned by like QA teams, and they handle their own coordination about who's testing what and where. And then using that strategy, we have an environment that's always online, that is already staged with data, that is pretty stable in terms of that data, so it's not constantly changing or getting wiped out, which is very confusing from a QA perspective. And then you use labels on your pull request to determine which one of those QA environments you want that branch to go to. So that way you have a coordinated way for multiple people to test something, or for QA teams to test something in an environment. And then you have a few other use cases. You have like load testing. Like you're never going to use those preview environments probably for load testing because they're not optimized for that. They're optimized more for preview functionality of features, but not for preview performance functionality. And that's why you'd have a separate environment probably for load testing. And then you have your dev environment, which is where after you merge to main, automatically head is deployed to your dev environment. And a staging environment would be where you have every one of your releases deployed to prior to going to production. Lastly, there's a hotfix environment if you're doing hotfixes, like more longer lived releases. And the hotfix environment represents basically a staging environment for what's currently deployed into production versus the staging environment, which is usually the next release of production. So that's a mouthful, but I guess my main point there is I think trying to generically solve on-demand environments is fool's errand. I don't think it's going to be achievable in the long run. Maybe for a pretty simple app, but not for more complicated things.
All right, thank you.
Sorry for the down news. Anybody else have a alternating or alternative opinion or thoughts on this?
I guess the only thing I'll add is that I've worked in an environment that had a very large number of microservices, so large where you could not deploy all the microservices on a developer laptop or on like a staging environment very easily within a reasonable amount of time. Like I'm talking in the hundreds, high hundreds of microservices. Yeah. And the way that we did that was we basically had like a preview environment cluster for all intents and purposes. We had the entire set of microservices planned there. And then you had a namespace for just the things that you were modifying. And then we had routing like in the actual service mesh. If you had certain headers on your request, it would route those requests for that particular service to your custom name only to test it, and then everything else would go to the deployed version that is not being modified at that point. So you could test third-party integrations. You could test with inbound webhooks. You could do a lot of other things with that. In that case, you didn't have to reseed data, all the time, et cetera, et cetera. You basically just had to opt in into the request headers that said what your namespace was, and then it would that would basically redirect. The mesh would then send it down to just your namespace for the thing that you're modifying.
Yeah, that's an argument then for sticking with a mesh like Istio and attempting to leverage that for what you're doing. So I stand by that. That seems feasible based on what you described.
And it's actually, it's a little complex to get up and running, but once it's up and running, it's pretty simple to do what you want it to do. And the only other thing is that make sure when you're doing that kind of thing that your service-to-service communications have schema versions, especially if you're changing anything, because then you need to make sure that they're communicating with the same, you know, when you're talking to a new version of your service, that you make sure that you talk to the right versions of the schemas as they pass messages between each other.
Okay, so you mean each service would have its own namespace, and then if there's like a preview environment of the other one, maybe it's like, you know, app one dash, you know, branch name sort of situation.
Oh, yeah. Well, yeah, actually what we ended up having was the entire set of microservices had like the preview environment namespace. It was just like preview environment or whatever. And then when you were on like PR26, you would launch one, you know, you would launch a new namespace that just says like auth service PR26, and then you deploy just the auth service if you're working on that into there, and then the rules on the routing mesh of how each piece got routed respected a header that was in the inbound traffic to figure out, like, it would say like auth service PR26 would be on the request, and then it would pass that all the way through all the other services, and then it would use that to know to talk to the right version of the auth service that was deployed.
Okay, and what about the auth service like database?
You would launch that, like if you were changing the schema or you needed to modify data or do whatever, you could launch that along with your auth service. Like presumably the only path into the auth service database is through the auth service like code itself. So you can decide whether or not you need to use the shared one or deploy a specific one just for this test because you're changing something in the backend schema or something along those lines. Yeah.
All right,
so Eric, as you switch to the title slide there, I figured out Vlad must be not here today because he's celebrating. I don't know if you saw that Jeff Barr retweeted his 3,000 container paper
really?
And talked about it and everything. So
wow.
And it was a big long discussion after that. So you know, it was pretty cool.
That's cool. I wish the best for him.
Oops. Yeah.
We'll have to ask him about that next week when he's back.
Hey,
Yep.
I don't know if you want to announce, but atmos.tools is now live. Looks like Andre got that launched. If you wanted to
it is.
use that out.
No way. That's cool. It's too early to really say that this is ready to go and flushed out with the documentation. I think it's a lot of the scaffolding in place right now that we're doing for Atmos. But yeah, we're launching the microsite for some of our tools. First being Atmos. So here you can see the new microsite for Atmos. Atmos is our tool for Terraform and Helmfile and you know, inevitably Packer and some other things as we get to it. It helps us define a hierarchical configurations to define infrastructure. So it's incredibly dry, and we'll call out to Terraform to bring up environments. So we use this to manage very large environments, you know, thousands of stacks, and keep configuration consistent and dry. And that's, yeah, thousands of stacks across, you know, dozens of customers. So, you know, thousands and thousands of environments. Yeah, well, more to come on this as we get back to it. I'm very excited about this. The site looks very nice to me. Next question was from the community. It's a good question, a fair question to ask. You know, when you're using Terraform to provision RDS, one of the requirements is to provide a master credential for the database. And on the naive thing is you put it in a variable and you pass it in there, and then, well, now you have two problems. You have this sensitive credential both in code, in your Terraform code or in a variable file, and you have it in the Terraform state. Well, the minor optimization to that is you can use random password, a Terraform resource, which will generate that password and pass it to the RDS database when you provision it. But now you have still that password in your Terraform state. So it seems like we just can't win. That really, I think there's a couple options. One is you do that, but you have something like AWS SSM that automatically rotates that credential on a periodic basis. Or two, you're using, I believe, HashiCorp Vault. I believe Terraform's integration with HashiCorp Vault can keep secrets out of the state, but I don't quote me on that one. Matt Calhoun, you know on that one?
On some resources, yes.
Oh, on some resources, but maybe not on the
Not on
database
all.
resource. Yeah.
Yeah.
So I don't really know what the fix is other than saying, hey, live with it or rotate it after you deploy it. It's an argument.
As long as you're not doing drift detection.
Yeah, exactly. Well, so you'd have to basically ignore changes
Life
on
cycle
that one.
on that one.
Like,
Yep,
exactly. Like Tyler, says here. But it doesn't look like life cycle changes is supported for that setting. So, yeah. Anyone else have a more elegant solution?
I don't have one currently. I just treat the state as sensitive and live with it. But one of the options I've been thinking about is to have a different system where you can sort of lease passwords and get back an address, if you know what I mean. I don't know of such a system yet, but that would be the thing, because then in the state, you would just have a reference to that particular external secret. Still, they would sort of pre-exist or something like that, or be generated on the fly, in this external system.
Yeah, I mean, that's like VGS kind of works that way, but very good security. They provide APIs for that. I think there's others. The problem here is that, well, Terraform needs to, the way Terraform's doing this is ultimately needs to determine if that value has changed. Though, I guess, why couldn't it just use a checksum of the value versus the actual value?
I think the problem is inherently that the data passes unencrypted through Terraform, right? So Terraform has to have the unencrypted value so that it can then call the APIs with the unencrypted value, like to set it on the resource. And the way Terraform works is that it then writes everything in its state unencrypted, like to state. And then obviously you can encrypt the entire state using like S3 encryption or whatever your backend happens to be. But I don't think there's any way around that until Terraform decides, what, as an example, things that are marked sensitive should actually be sensitive and not be written like to state, at least unencrypted. It could write an encrypted version, but it shouldn't write an unencrypted version.
Yeah, I agree with that. All right, we are out of questions. Anyone else have some questions to bring up today?
I do.
Oh, fire away, Isaac.
If you had the privilege of helping a company start fresh with your AWS account, how would you go about setting up policies for IAM? Is there any documentation apart from like the AWS user guide and best practices that anyone can point me towards with regards to thinking about, least privilege access and what sort of system you should have for assigning users roles?
How large is the company? How many people are working with the infrastructure?
About 100 people.
Okay, this is sizable.
Yeah.
And how many people need to have actual, like, or what is their, how are they interacting with AWS? Why do 100 people need access to AWS? And, you know, could you move more towards a GitOps model so you don't need that many fine-grained permissions for people with full control and everything else happens through GitOps and policy?
That's definitely something that's on the roadmap, but it's gonna take time to drive everyone to that. For starters, since we're setting up new accounts and looking at just limiting access to, for instance, dev accounts, as opposed to the current situation.
So, I mean, Control Tower will help you with some guardrails and get that set up more easily and managed. If you're looking for Terraform support for that, we have our components being published and upstream, but all of our documentation for using them is closed source, is kind of what we exchange to our customers. If you go to Terraform AWS components here, we are actively upstreaming a lot more modules now. You'll be seeing them here. So how we're managing that is with IAM primary and IAM delegated, but these are old. We have much newer ones as of a month ago that need to be pushed up here. So that's the best I can do.
No, that's helpful. Thanks.
All right. Anybody else have something to ask? Well, we can end things a little bit early then today. Give you guys back 10 minutes of your day. I'm sure everyone can appreciate that a little bit. I want to thank everyone for their questions and their time today. If you haven't yet joined or subscribed to our YouTube channel, go to youtube.com/cloudposse and subscribe. It helps us out a great bit. If you'd like to connect with me on LinkedIn, just go to linkedin.com/in/Osterman and let me know that you're part of Office Hours. I'd be very happy to connect with you. If you're interested in working with Cloud Posse at some time, we just have a really quick little quiz you can take, cloudposse.com/quiz, to help figure out if we're a good fit for what you need at the stage that you're at. And if you would like to participate in our very active Slack community, head over to slack.cloudposse.com and you can get a Slack invitation there and join our community of other DevOps practitioners. So with that said, thanks everyone. Have a great rest of your week. Talk to you soon.